Hey kids, good morning. It's Saturday, just roll out of bed, ready to fucking do some fucking shaders. So today we're gonna talk about transformations, or at least one part of transformations. But before we start with any of that, just gonna hop into the internet. We're gonna Google our way into GLM. I'm gonna go into this OpenGL mathematics, alright? Because we're gonna do some fucking mathematics and it's gonna be great. Hop into releases here. So I'm just going to releases. And I'll download this zip here. Boom. Check it out. Why is this like the most unreliable fucking function in okay, there we go. Okay, so I'm just gonna extract it. Okay. Let's see. What do we have? There's some stuff. We want this GLM here. So that's the include. For some reason, they didn't put it in like an include folder that you usually do, but hey, that's C++ libraries for you. It's like no standard. It's all willy-nilly. Let's go into graphics course, include. So I'm just going to copy this GLM folder in there. There we go. And what's so nice about GLM is that it's an include-only library. So there's no libraries or DLLs to worry about. It's all header files. Good. And unlike this STB image thing, there's no like you have to define implementation or anything. This is actually header only. So that's quite nice. Let's just see that we can include it. Just to make sure we didn't mess anything up. So I'm going to do glm.hpp. It's giving me an error, but I'm guessing that's BS. It's BS. Okay, thanks IntelliSense for being so helpful. Great. So before we start doing something, doing stuff in here, we're gonna talk. I'm just gonna give a brief introduction to what we're gonna be talking about, which is transformations. And I'm not gonna explain transformation as a concept because it's so broad. It could mean so many different things. We're simply these few videos coming up. We're gonna take one corner of transformations at a time. We're going to explore one corner, and hopefully by the end we'll have a more or less broader image about what transformations could mean. And the first type of transformation we're going to talk about is something called a translation. So in this case, a transformation is applied to every vertex. So we're transforming each vertex of a draw call. And in our case, we're going to apply some transform T. I'm just going to write T, usually do capital letters, bold to denote transformations. So I'm going to apply this transformation T to each of these vertices. And in this lesson, we're going to do a translation. A translation applies an offset to each vertex, and it's a uniform offset that moves each of the vertices the same amount, like this. And that's what we're gonna do. We're gonna do a translation transform. All right. So, what does the transform look like in code? Well, in it depends on like which engine you're using. There's multiple ways to do transformations. There's not just one way, but one very convenient way that encapsulates a lot of transformations is something called a matrix. And you might have seen The Matrix. It's a good film, I think, especially the second movie. It's really good. We're not going to go into the specifics of what exactly a matrix is and how, matrix multiplication works, because honestly, I don't think that's super important. Since matrices aren't even the only way to do transforms. If you're working on a real engine, for example, their F transform is not the same as a matrix. It's not really, they aren't equivalent. They aren't exactly the same thing. So I don't think it's super important to realize to understand exactly how a matrix works. The only thing we need to worry about is what does the transform do. That's sort of what I want you guys to take away from this. So translation, moving vertices around. So we're gonna use this GLM mat4. All right. So if you really care, that's a 4x4 matrix. Quite cool. So we're gonna call that the translation. All right. And the way we construct a translation matrix is we type GLM no. Okay, so I think we need to include something. We're gonna include GLM GTC, I think. God, it was so long since I did. There we go. Matrix transform. All right, so that's a bunch of helper functions to create transformation matrices. So we're gonna include that. Specific doesn't matter. Don't worry about it. So we're gonna do translate. There it is. All right. Excuse me. So, I mean, this is what I don't like about GLM. It's quite hard to read the. It's quite hard to read the signatures. Okay, so it takes an M here, and this M is essentially which matrix to apply the translation to. We're not actually going to use this at all because I don't think it's very helpful to understanding how transform multiplication really works. So I'm actually going to always pass in something called the identity there, and what that means is just don't do anything, don't use this essentially. So I'm just going to do GLM identity, and then I think I need to do GLM mat4 as well. GLM, not the most useful library, but it is very, very powerful. Excuse me. All right, so let's see here. So we're gonna do a translation matrix. We're not gonna have some sort of base matrix to apply this to. You know what? Fucking whatever. I'm just gonna fucking use namespace. Using namespace. GLM. I don't want to type GLM in front of everything. It's super annoying. So let's just get rid of this. There we go. This becomes a little bit more readable. All right, so translate. Okay, so mat4. That's just which matrix to apply to, and we just pass in the identity. We don't care. And then here is the vector to translate each vertex by, and it's a vec3. So we're just gonna pass in a vec3, and let's do 0.2. Nah, let's do 0.5 actually. So I'm gonna do 0.5, 0, 0. So, okay, there we go. So now I got the translation matrix here. And this matrix, if I apply this transformation to each of the vertices, I should move them 0.5 units in the x direction, because that's what I entered here. Great. It's okay if this is confusing. It's okay. We're gonna unpack this as we go. Hopefully by the end of these few videos, it will make more sense. So how do we do this? How do we put this in the shader? So I'm going into our vertex shader here. So I'll make another uniform, and I'll make a mat4 uniform, and I'll call it U translate. Yeah, that's good. All right, so I made a U translate here, and that's gonna be our translation matrix. I'm gonna put that in there. So let's do that. So I'll get the uniform location here. So I'll do U translate is GL get uniform location program U translate. There we go. So now we just have the uniform handle there. And then, okay, so how do we upload a matrix to the shader? let's see here. So we do GL uniform. And then there's a class of uniform functions called uniform matrix here. So there's a bunch of those. So they work, the naming convention is quite roughly the same. So in this case, the number is the dimension of the matrix, all right? So we're using a 4x4 matrix. Again, it doesn't matter. Like, don't worry about this. You can do other dimensions if you want, but uniform matrix 4x4 is by far the most used one, the most useful in this case. So we're gonna go, okay, GL uniform matrix 4. So 4 means 4x4. Here's like 4x2 and so on, but 4 just means 4x4. And then there's a few types. There's 4DV, and that means an integer matrix. And here's 4FV, which means a floating point matrix. And here's 4VBRB, which I don't know what that means, so I'm just not gonna mention it, but I already failed on that. Okay, so this is 4FV. So that means matrix 4x4 float, and V, if you remember the naming conventions of uniform functions, V meant that we don't type in the numbers in the function, we provide a pointer to where the data is. And this is the only way to do matrices in OpenGL uniform that I know of, because it's annoying to have to type in 16 values in one function call rather than just providing a pointer to some data. It's just too many numbers. They skipped that type of function. Okay, so location, that is the uniform location. So we'll just do utranslate. Then it's count, so that's how many matrices we want to upload. And in our case, we just want to upload 1, and that's if you want to have arrays of matrices. Then we have transpose, and I'm actually not going to talk about what transposing means. We're just going to type false, all right? Again, it's a technicality with matrices that sometimes is useful, but in our case, it's not. And here's a floating point pointer, and that's just the pointer to all of the data. So we could make an array, for example, if we wanted to use an array of floats. In our case, we have this matrix 4, and you know, if we were to look into the matrix 4, if that's even, yeah, no, okay, let's not do that, because that library is so annoying to look at because it's just templated everywhere. It has all the floats, you know, just in row. The way you get a pointer to the floats, I suspect we could just take the pointer to the structs, because I'm suspecting the floating points of the matrix to be just all there is to the matrix. So we probably could just get the pointer to the mat4 and convert it to a floating point, a pointer, and that would work. But they have a very nice function for this to get just like converting a struct like this to a pointer. That's in GLM GTX, I think, and then it's value something. It's so long since I did this. Maybe I should use right pointer. No, it's something pointer. Should have looked this up before. Crap. I don't remember. What if I do a symbol search? Maybe it works. Where is that? Can I get like file? God dang it. Okay, let's value pointer GLM. I'm sorry guys. Here, type pointer. There, value pointer. This is one we want. And where is that? GTC type pointer. Okay. So it was not GTX, it was GTC type pointer. I'm sorry. There we go. I should have looked this up before. So we want to include this type pointer because then we get the value pointer function, and that takes some type of struct and returns us the pointer to the first floating point, which means that we can pass that in to OpenGL and pretend it's an array really. So we're gonna do a value pointer and then pass in our translation. There we go. So now that should work. Yes, okay, there we go. So now we have taken our translation matrix, uploaded it to excuse me, uploaded it to our shader. So we have our translation matrix inside of the shader. Great. Okay, so now how do we apply it? Okay, so now if I run, obviously nothing will happen because we aren't using the matrix at all. So how would that happen? Like we have to use it. So okay, so how do we use it? Well, the way you use matrices is that you multiply them on things. So there is no addition in matrix algebra. There is only multiplication. So what I'm gonna do is that I'm just gonna multiply it by this vec4 here that we produce here. So I'm just gonna do translate times vec4 a position 0, 0, 1. And let's see what happens now. There we go. So now it's translated by 0.5. Okay. So I know I'm asking you guys a lot to ignore basically everything I'm saying and just try to focus on the particular thing we're trying to do. Focus on the goal. And I might make like a complimentary video talking about actually what matrices are and what matrix multiplication is and stuff. We'll see. For this lesson, I just wanted to get it up and running, like getting GLM down, making a matrix for the first time ever, and getting it in the shader and seeing what happens. The most important thing to take away from this is a matrix is some sort of object that does some sort of transformation. So that's point one that's important to take away from this. The way you apply matrices to vectors is by multiplying. Take two. I think that's it, actually. I think those are two important points to take away from here. We're going to talk about the other points next video or later videos. All right, I think I'm just going to move on from here. Ask questions in the Discord if you want me to explain stuff. I've deliberately really peered over stuff now because, this is not a mathematics course. It is supposed to be a shader and 3D programming course. I don't think it is important to know what a matrix is exactly. But if you guys are interested and think it's confusing when I don't explain what a matrix is, then let me know and I will do a video about explaining more what matrices are. I might do it anyways. Just to give you guys a little bit of context to the mathematics, why we're multiplying and why do we have to multiply, which I haven't even mentioned actually. We have to multiply a 4x4 matrix by a vector 4. There's not defined to multiply a matrix 4x4 matrix with a vector 3 or a vector 2 or anything. You have to multiply it by a vector 4. And the W component has to be 1 or this won't work. If I do this if I make a 0 here, you're gonna see it might not even show up on screen, honestly. No, it just kind of explodes. Like the whole screen is now fading, so it has to be 1. Why is that? It's complicated. It has to do with matrix multiplications and stuff like that. Yeah, I think the best way is to just move on. Do some more transforms, get a little bit of familiarity with it, and then maybe it will make more sense. So, don't panic. Let's just move on.